Thanks. My name is George Williams, founder, CEO of a company called Reliability X. We're a fairly young company, 3 years old. Perhaps a safety moment is a good thing to start with. Why do we wear seatbelts? Yeah, we wear seatbelts because an accident is something you can't foresee. You don't know when it's going to happen. And at this conference, you don't know when your aha moment is going to happen. And so I would encourage you to be here. Encourage you to close your laptops and pay attention to the presentations, because it's not going to be known when your aha moment occurs. Which presentation it is, which speaker it is, it's not going to be me. And so be here. There's a lot of opportunity between all of the sessions. Visit the session, take advantage of that. Don't sit by the pool. There's not a beach here. That's a good thing. We're not really at that type of resort. So make sure that you're in each presentation. So we're going to talk a little bit about the evolution of maintenance. But in order to do that, we got to talk about the evolution of industry. And so we've got to walk through a little bit of history to understand why the maintenance organization exists and what their purpose is. Industry 1.0, this is, oh my goodness, steam and water power. Steam locomotives, water wheels. The one picture here is the Kilbeggan Distillery in Ireland. It's a distillery that functions off a water wheel, single shaft, through the whole plant. So whether you're in the mashing area or the bottling area, you just pull a lever and a gear engages, and that wheel drives your production. Maintenance in that era still had basic controls. Heck, the water wheel has a VFD. They turn the dial and it moves a baffle, and that adjusts how fast the wheel's going to spin. So even then we had controls, and we needed controls technicians, although all they had to do was turn the wheel. From a maintenance perspective, maintenance and PMs were really geared around safety, whether it was life safety or lubrication. That's kind of all that existed. And when it broke, we had to repair it. So we were completely reactive as an organization. In Industry 2.0, we have Henry Ford, the implementation of the assembly line, and that changes a lot of things. Electricity changes the world. Mass production and division of labor. Division of labor. Oh, I deal with this all the time in planning and scheduling. Who has implemented planning and scheduling? Anybody implementing planning and scheduling? Just a couple. Okay. Oftentimes, the trade staff come to me and go, well, I can plan it myself. What do I need a planner for? If I can do it all myself, what do I need that for? The day before Henry Ford turned the switch on the assembly line, everyone in the plant could build a car. It didn't make them wrong. The division of labor streamlined things, and allowed us to become more efficient. But it also meant now I need maintenance folks who work on the machines that make the machines that we sell. And that didn't exist before. And so a whole pool of talent was now required. Also in Industry 2.0, we have machines that are built to last. How many folks have pumps that are 40, 50 years old, running like a champ? That thing is never breaking. It's not very efficient, but it's never going to break. These are pictures from Lake City, Missouri at the Army National. It's an ammunition factory run by the Winchester plant. I toured this facility. And those machines are all from World War II, and they beat the crap out of billets to make bullets and shells and casings, 9 million rounds a day through sheer force. And this maintenance organization said, man, we're cutting edge. We've got automatic lubricators. We've got this. We've got that. They took me for a tour of the plant. I walked around, and all the pins on their automatic lubricators are pushed out, which means no lubrication's getting to the equipment. There's too much back pressure. So while they implemented things, they had no education around what it was doing and why it was doing it. And so it wasn't functional. It wasn't actually producing results. We see that a lot within most maintenance organizations that sit in this 2.0 realm. So now we needed equipment that, we have equipment that produces product. In the 20th century, early 20th century, we start to see apprenticeships because the skill requirement is massive. Because now not only are we manufacturing equipment, we need people to work on the equipment that's manufacturing equipment. And so there's an awful lot of apprenticeships that take place. And in 1937, the government created the National Apprenticeship Act that required registrations for apprenticeships. Oddly enough, during this same time period, most of the technologies we use in maintenance, reliability, and asset management were invented. Infrared thermography, ultrasonics, vibration analysis, all of these technologies that we use to diagnose and understand the health of our equipment are, at this point, 70 years old. In most plants, they're either non-existent or they're collecting dust. And they're underutilized, much like software solutions are. In addition to that, the techniques, the actual techniques, reliability-centered maintenance, failure modes and effects analysis, are also invented during Industry 2.0 and are still rarely applied. How many people walk around their vehicle each and every morning before you drive it? How many people check all your fluids? How many people check the left blinker and the right blinker? Why are you not doing that, but at your plant you're using the OEM manual? We recognize that in an engineering world, we have reduced the probability of failure. We now have a dummy light that pops up that says my tire pressure's low. Why would I check it every morning? But the manual still says to do it. We take that same logic in our head and why we didn't walk around the vehicle, but we don't apply it to our plant. And we do things because we were there. I have to lubricate it every 3 months, so while I'm there, I'm going to check these 50 other things that don't need to be checked. And this is where we get stuck in Industry 2.0. We don't apply technology and we don't reduce the amount of work we have. In addition, the CMMS is invented during Industry 2.0, as Larry pointed out. The other interesting thing about Industry 2.0 is somebody called up the Ford factory and said, hey, by the way, a part broke, I need a replacement. And the person on the other end went, wait, what, I can sell parts? So if I reduce quality and I don't need a pump that lasts 50 years, and I can sell the parts, that's a whole nother value stream and money that's coming in. Let's reduce quality. And procurement loves that. Oh, I get the cheapest stuff. Let me go buy the cheapest stuff I possibly can, regardless of how long it lasts, right? So now we also need people who install them. So I need mechanics that actually just install parts that I didn't need. So no longer do I just need maintenance on, my carriage or my steam engine. Now I need maintenance on the equipment that builds that, and I need people to go out and install the parts. So the required skill level in maintenance keeps increasing. Industry 3.0 pops up, and here we've got ladder logic, we've got communications between devices and IOs. Oh my goodness. Low voltage communication changes the world again. We now have SCADA systems and robotics. Our CMMS can be integrated to other things. Oh, ladder logic. I remember ladder logic in high school. But now we need a controls technician. Now I need somebody that can program in maintenance. So I went from somebody that could, just grab a mop bucket with some grease and put it around a wheel to somebody that can program. The communication between controlled devices allows me to now have a SCADA system, a supervisory control and data acquisition system, where I can see and visualize the entire plant. And I can make decisions. And I can see when my pump fails. I'm still reactive, though. I'm still saying, hey, the pump's down. Put in a work order. Put in a work request. So we're still reactive, even today, right? Most plants that I go in were extremely reactive. Now, not only can the devices talk to one another, they can make decisions. They can help you make choices. Industry 4.0 not only connects those devices, but allows you to put parameters in place for those devices to make decisions. This is the weird thing about Industry 4.0. Anyone that's in a continuous flow process, whether it's liquids, dairy, biologics, doesn't matter, this should be the first thing they're driving towards. If you can control output quality by learning input parameters and variation, you can always have great quality. For basic things, this failed, trying to be reactive again. The world's not quite understanding the technology. The technology is there for it to run everything if you let it learn. And we still use it as a reactive piece. Oh, let's get all way into this. And then we've got machine learning. So in this technology, this is pretty amazing. This is great stuff. You basically tell it what good looks like. And every time we don't run good, you tell it what bad looks like. And it starts to learn what bad looks like. And it sends an alarm way in advance because it can see those parameters. When we engineer product and process, engineers sit down and they say, okay, well, pH can be between this and this, and temperature can be between this and this, but they don't know the exact relationships of when all of them are low or all of them are high, or what if this one parameter is low and this one parameter is high, what that means to output product. But machine learning does. It learns it over time. The same thing with our maintenance systems. Machine learning can help identify parameter defects, whether it's lack of lubrication, too much lubrication, wear component degradation. It can pick those things up and begin to give us alarm points. Man, this is a great place to be, but that's unfortunate because we're not there. Let's see where we should be. So in Industry 1.0, we're completely reactive. PMs are for life safety and lubrication. Industry 2.0, we have component wear, and we replace components based on wear. Predictive maintenance exists mainly in the military, and we have highly skilled staff. That's what we should have. In 3.0, we're proactive. We should be using things like RCM and FMEA, the reliability-centered maintenance, failure mode and effects analysis, to determine our strategies. We should be planning and scheduling work, and we should still have highly skilled staff. As we move to 4.0, we should be intuitive. The asset should be telling us when it needs maintenance. We have the technology and the capability for the asset to provide us detail in which we react. Here's the reality, though. In 1.0, we're reactive, right? That makes sense. 2.0, we're still reactive. We're still reactive in 2.0 today. We PM wear components. We own PDM tools, but we don't use them. And our skilled staff is retiring. That's the reality we are in today. At 3.0, we should, using our PDMs, the FMEAs, we're not really using those. We're scheduling, but not really planning. And our skills drop. Interestingly enough, Tony brought up the disconnect between maintenance and the business. Most organizations, most manufacturing plants, they do two things. They R&D new product, and they operate and maintain equipment. That's it. Everything else is a support function. Everything. And as they expand in technology, they think they're going to reduce headcount. Well, we're going to put in all these robots, still have really low-skilled maintenance staff. Who's taking care of the robots? They justify technology in reduction of headcount. I have clients all the time, they say, we're going to put in this case erector so I don't need a person. And when I go, well, who's loading the car again? Oh, we didn't think of that. Who's going to fix it when it breaks? Well, we'll just dump more on the current maintenance staff. How many people find themselves in that position? The maintenance staff is overwhelmed now. So unfortunately, while we should be at an intuitive place, we're not quite there. Let's explore why. From my perspective, there's three things for us to be successful in asset management, maintenance, and reliability. The first one is sound processes. We have to have processes that support the business. We also have to have systems like EAM. And those systems have to support the business process. And then we have to focus on people. They have to be educated and understand why they're doing what they're doing. The processes that exist within maintenance and asset management are basic things like, do I understand criticality? What do I own? How critical is it? How does it fail? How do I develop a strategy around the asset? How do I utilize EAM for that strategy? Whether I'm going meter-based and cycle-based, or whether or not I'm using a PM schedule, how is that derived? They're all processes. How you'll do those things are processes. The process of asset management is a basic plan, do, check, act cycle. In the planning phase, we connect organizational goals to asset management goals, down to the asset. And this could even exist inside EAM. You have a whole area for managing your policy statement, for managing objectives down to your asset management system. Then there's the whole asset structure, the asset portfolio. What do I own? How critical is it? And if it's critical, how does it fail? These questions help develop your PM tasks that connect to your PM schedules. We ask a series of questions about critical failure modes. First one is, can I engineer it out? Can I get rid of it? If I can get rid of it, fantastic. Then I don't need a maintenance strategy. The next question is, well, can I assess its condition? Whether I use AI or predictive technologies, how do I assess the condition of the asset? If I can't do any of those things, then I have my PM schedule, and that PM schedule may include what's called a failure finding task. Failure finding tasks are things like e-stops. You can test it all day long. You don't know if it's going to work when you need it. All of that strategy feeds into getting the work done, the do section. This is where you're managing your breakdown maintenance, where you're managing everything that's corrective, where you're managing your backlog, where the rubber hits the road. We have to get the work done. The next piece is reliant on everything you have structured and configured inside EAM. It's the analysis phase. And this is going to be based on how clean your data is, whether or not there's gray lines in work codes, whether or not you've set it up appropriately, and whether or not you're using closing codes. That data analysis is not just limited to EAM. It can also use data from your SCADA systems and from your ERP and all of those things. And that feeds into making adjustments to your process, changing the PM strategy. We have to take actions. If we're in this room today and the maintenance organizations we support are reactive, looking up at the moon tonight and wishing tomorrow we were proactive isn't going to cut it. We have to take action. That action is based off of the data and information you get out of this system. How well you structure it and get utilization and train people on it really dictates your ability to make good choices and become proactive. Here's why maintenance exists. In the 1970s, the airline industry did studies on component failures. And what they found was components fail in one of three major categories. First one is infant mortality. This is electronic components that don't burn in. This is warranty issues, things that fail right after we put them in because we didn't put them in right. All the way on the far right is wear out. This is stuff that was built in the 1930s and 40s. In between there is the failure pattern called random failures. If I take two pumps brand new and I install them right next to each other, they're doing the exact same thing, turn them on, they are not going to fail at the same moment. That makes their failures random. When we design equipment, we design it in with a baseline condition. You can buy a Yugo or you can buy a Toyota Corolla. Baked in there is how much you will spend in maintenance. So we have a base condition for the asset. The role of maintenance is to manage degradation. So from that baseline condition, over and over again, we degrade and restore the base condition. Lubrication is missing, we lubricate it. The belt is wearing, we replace the belt. Over and over and over again. The role of maintenance is to restore to base condition. The inverse of that degradation is the cost of being reliable, direct to the business. As a bearing needs lubrication, it requires more energy and more electricity because of the friction. So as components wear, cost goes up. We restore to base condition, costs come back down to base condition. You use the features inside EAM to say we need better design and to build better maintenance strategies using techniques like reliability-centered maintenance and FMEAs to raise your base condition. When you do that, you also change the rate of deterioration. You use things like automatic lubrication and predictive maintenance. You're reducing the rate of degradation of your parts. You use precision maintenance techniques and have trained, well-skilled people to reduce degradation. Now, eventually, this thing's going to fail. Somebody gets a speck of dirt in a bearing, and we have a point of failure. We use predictive technologies and AI and machine learning to find that flaw. The reason we do this is not because they're cool. Man, we got these cool technologies. That's not the reason. We do this to give you maximum planning time. The earlier I know it's going to fail, the more time I have to plan it, the more time I have to work with operations to get the asset, and the less likely for other damage. When a roller bearing fouls, catastrophically, we often have to replace the shaft because we scored it. That doesn't happen if we predict it early enough and just replace the bearing. So eventually we're going to have this catastrophic event. If we're only using our senses, we're reactive. We're rush ordering parts. You want to know if you're reactive? Just look up how much you spend in extra shipping. And that tells you. If it's 0, you're proactive. If it's not 0, you're reactive. If we wait till we use our senses instead of technology, again, we'll have the catastrophic failure and costs go through the roof. Maintenance can be a profit center. Maintenance can lower their cost. Maintenance can have minimal impact to operations. But they have to use this system. They have to configure it right and use the information that comes from it. The systems that support all of these processes are EAM in your SCADA system, the ERP, if that's different, and your data lake, data warehousing, whatever solutions you're using from an analytical perspective, they all have to support what's going on. From an EAM perspective, we have to configure it with the end in mind. Data quality has to be king. Make sure your measurements are geared towards improvement opportunities, not just performance. Your dashboard's PM compliance, great. It was 99, fantastic. It was 89, what am I doing? What action are you taking? The results you get should be giving you decisions to make, not just performance. Performance is in the past. And capture what you need for those measurements, either procedurally require it or allow the system to require it. If you want the data, require it. Otherwise, it doesn't usually get captured. Oftentimes, we work with a lot of clients, not just EAM users. So it's not anything to do with EAM necessarily. Oftentimes, when we go to clients, the first thing they say is, well, our CMS is terrible. Our EAM's no good. It's not doing what we need it to do, so I can't really plan and schedule. I can't do this, I can't do that. And when we dig into it, it's because they configured the system wrong. And they just can't use the technology that's embedded because they've configured it in such a way that makes that functionality useless or not as useful as it should be. So one of the big criteria for success in utilization of the system is educating people how it actually works at the design intent level. I can't tell you how many times folks that I've dealt with say, well, we told the vendor we wanted to do this or this, and somebody thought it would be a good idea to use this field for this reason. And then that use 20 years ago now makes it impossible for them to do what out-of-the-box functionality can do. And that's an education piece. Leveraging EAM, we should be able to pull things out that allow us to be more proactive. What does rework look like, and how do you pull it out? Mean time between failure. Where am I spending all of my time? Where am I spending all of my money? I remember doing this analysis years ago, and we had a plant in Manatee, Puerto Rico with a lyophilization system that was the most reactive asset in the entire network. It was also the most expensive to PM. So was the PM strategy very effective? Not at all. So we had to revisit that. And what about operator assistance? Oh, for the people that are users in here, go in your system if you're in manufacturing and look up all the work orders with no part. Most of those are going to be going out to an operator, making a tweak at the line, nothing broke, but maintenance is getting blamed. We have to be able to pull that stuff out. So we have to focus on people first, which requires us to focus on leadership and how we lead people and whether or not they feel engaged and they understand the importance of maintenance. In this room today, we've got not only the vendors that support EAM and the folks that use it, but we also got people that focus on life safety and quality of life. Whether you're in food manufacturing or in wastewater, you're supplying valuable resources or energy generation. You have an important role in making sure quality of life for people. And in some cases, just their own life safety. They have to be well trained, and this is a gap we're going to talk about. And they've got to be empowered. But the interesting thing about empowerment is it's not just somebody standing on the stage going, you're all empowered to make a difference. How good does that work? How many folks are in an organization where the leader stands up and say, everybody in my organization is empowered to make a difference? And if you make a mistake, you're in somebody's office. Empowerment requires not only being told you're empowered, but it requires the recipient of the empowerment to have the confidence to act on it. And having the confidence to act on it requires training and a culture where you're not going to be, where it's okay to make mistakes. If those two things don't exist, you can tell people they're empowered till the cows come home. No one's empowered. Where we should be, skills. We have to be at a place where we've got a skill level that's appropriate for utilization of the system and making a difference. Interestingly enough, there's an organization called Scientific Management. Has anybody ever taken the Scientific Management test? They test you for mechanical aptitude. And they've been conducting this test for decades. And they keep track of every score. Look at the trend since 1998, 99. The average score of this test has dropped by 2/3. We have no mechanical aptitude. And the technology of our machines keeps getting higher and higher. So our troubleshooting skills and mechanical aptitude keep getting worse, and the machines keep getting more complex. I hope your capital budget's huge, because you're just going to be replacing assets, because it's the only option we're going to have. If we don't focus on people, it's the only option we're going to have. And we have to recognize skill sets. This was a problem for me forever. I was a STEM kid. I wanted to build stuff and rip stuff down and almost rebuild it. This is something we have to drive, not only in this country, but worldwide. Putting people in STEM programs and recognizing their skill sets and putting them on a path towards that success. I didn't always have that luck. When I was my mother kept all of my report cards. And when I was in grade school, these are the things that I would be told. George talks too much. I'm not kidding you. Here's another one. He's a nice little boy, but he's talkative. I've memorized most of a poem. Not the whole thing, just most of a poem. Oh, and by the way, he talks too much. I'm starting to do an awful lot of talking. This is years later, so this is a teacher that clearly doesn't look at my records. And this one's my favorite. George needs to control his talking so others can learn. I'm not there for anyone else. Guess what? I talk for a living. We need an education system that supports skill sets, that looks for what your aptitudes are and focuses on them, and looks at what the organization needs and then supplies that education. We work with a lot of clients on things like a skills matrix, where we take all of their equipment and decide, well, how good are they at troubleshooting it? And we create skills matrix. Are we providing people the necessary skills to reach our organizational objectives? How are we going to support Industry 4.0 if we can barely fix a sandwich? How's that going to happen? We've got a team of people in the room. We're working on the technology to make things happen. And on the other side of the fence, we're trying to reduce headcount. And we don't invest in people. It's scary. What can we do? We can try to educate people in the proper utilization of the system, in how much administrative work it is to maintain a system, because lots of folks just think, you buy the disk. I just buy the disk and I put it in and that's it. It's a lot more than that. Performance is a lot more than just the asset. Surrounding the asset are all of the processes, what an operator does, what a maintainer does, how you manage that data inside EAM and leverage it to get better. You have responsibilities as the operator of a vehicle. We don't call up the mechanic and go, hey, the car needs gas. That's not how it works. You're the operator. It's your responsibility. There's maintenance work that's the responsibility of an operator. Are we leveraging EAM for that? We should be. They have responsibilities. It's part of maintaining the equipment. Cleaning standards, inspections. EAM can manage all those things, but most plants don't use it for that. They only use it for maintenance. Well, guess what? That is maintenance. It's just not done by the maintainer. It's done by the operator. The biggest gap between success and failure is the culture of the organization. You can have all those great tools. You can have a great implementation. I'm sure that from the vendor side, you guys have patted yourself on the back on amazing implementations that that particular facility has made no improvement from a maintenance perspective. It's just a culture of, well, we blame maintenance. How do we support that? How does EAM support that? All of the data coming into that system can be utilized to make the plant more reliable. And when the plant is more reliable, people are happy. Whether it's manufacturing or service industry or public utilities, if things run smooth, people are happy. Maintenance provides quality of life. The system that you either are using or support or design or sell and implement provides quality of life. If used well, the maintenance manager's feet are on their desk. That's what it's for. There's a balance between the use of people, processes, and systems. And it takes a combination of all three to create sustainable results. If I have great systems, I have a perfect EAM implementation. It's awesome. And I have good processes, but I don't focus on people and they're not well trained, they're not going to use the system, they're not going to see the value, and just total failure. If we have great people and good processes, but they didn't configure EAM right, they have other systems that are no good, if the system is not supporting them, they're frustrated. You create frustration and limited success. The system has to support their business. Now, if we have good systems and people, but no process, then we're talent reliant. That means if we have this amazing admin, they do an amazing job and everything runs smooth. But if they leave the company, we're starting over. Worse yet, if you find yourself in that position, if you feel like you're irreplaceable, the place would shut down without you, you're also unpromotable. Why would I promote you? I can't live without you in the seat you're in. So we have to have processes so that we can have people raise their level of education and get promoted. Just some final thoughts. Whether you're a user, a designer, an implementer, an integrator, sales, leverage what EAM can do. There's a lot. In my review of the system, it supports everything you need to do from an asset management perspective, everything. Oftentimes, people don't know its design intent. Learn all you can about the business of asset management. You're selling it. Whether you like it or not, that's what you're selling. If they buy the software, can't use it right, and don't see any success, did we service them? We made a sale, but we didn't service them. So if we're truly of service, we have to learn the business side of that. What's the use case? Why do we use it? Why does it have an asset management policy section? Why does it have standard work order? What is that? What's the use case of a standard work order? Don't make me put you on the spot. And use data to drive those improvements. And focus on people, because Industry 4.0 is coming quick, whether we like it or not. And I'm sure we all love it. But we need the skill sets, the processes, and the system to support what's about to get implemented. Because without those things, it's going to be tough for us to move a maintenance organization along their maturity. Make no mistake about it. The only way you're moving from one phase to the next is if the culture moves. You can't move faster than the culture can evolve. It just doesn't happen. And the evolution of the culture is how they understand the system. Can they connect it to their everyday work? Can they utilize the system? We have to raise not just the level of complexity of the equipment, but the skills of our people to a level of understanding, because the culture doesn't change just because I said use it this way. That's not enough. If they understand it, the culture evolves. If we can evolve the culture, they get better. So whether you're a user, whether you're selling, whether you're a designer, focus on the use case. Educate folks on why the design intent exists, not just this is how you use it. We have to get them to understand the business logic of why. And only until they understand the why will utilization go up. All right, awesome. You've been really awesome. I'm George Williams. We'll see you the rest of this week.
Thank you, George.